pick and choose what I'm going to talk about. But you've got it all there on Tulip, and you have things to fill in any gaps that you really have. So this issue of the penetration of domestic animals into southern Africa is extremely interesting. It's been very, very relevant to the recent history and prehistory of southern Africa. There were no domestications of either plants or animals in southern Africa. All the animals and plants that are domesticated and are part of the history of the last couple of thousand years were all domesticated somewhere else. And so it's about the penetration of these things and to what extent they were accompanied by people or not. And this is a very interesting issue because, of course, and it highlights some of the methodological things that we've been talking about. So, for instance, it's not going to be good enough for you to date the charcoal, let's say, in a fireplace, in a layer, and then say, oh, and I've got a piece of sheep here. So sheep must have been here, let's say in some part of Namibia or on the southern coast of the Cape or whatever, at 2,000 years ago. Why? Because, of course, the date that you're relying on is the date related to the charcoal in the fireplace. And it may be that the sheep doesn't really belong stratigraphically to that horizon. And that happens a lot. Archaeological stratigraphic excavation, because these are all soft sediments, and people are digging with trowels and brushes, you know, it's very, very easy, however good an excavator you are, it's very easy for things to be misplaced. And it's also possible that there were, at the time of deposition, that there were people digging pits to sleep in and all that kind of stuff. So we've had some very early dates for the appearance of sheep in southern Africa, which have turned out not to be reliable. Partly because they're not the same age as the horizon where the fireplace was, and the fireplace was dated, but they've, for whatever reason, they've got in there. So you've got to directly date the sheep bone, right? And then the other problem is you've got to make sure it's sheep. And something that you'll see a lot of today and tomorrow is morphology, morphological identification of sheep rather than some equivalent wild bovid. When everything's broken up, you know, you'll know by now, the archaeological record is sort of broken things and fragments of things. So some faunal analyst may tell you this is a piece of sheep, but it might not be. And we've had that problem as well, that pieces that have been identified as sheep or goat or cattle have been analysed genetically and found not to be domestic stuff, but to be an equivalent wild bovid that is morphologically very similar and has been mistaken for sheep. So this is an important issue, but it shows how different archaeological techniques have to be combined before you can be sure you've got a piece of happening that you can rely on and that you can interpret. I wanted to say that about that image. We talked about tree ring dating and ice cores and various kinds of science-based dating, let's say. Paleomagnetics, we talked a little bit about this. I also want to make a point about this. At Olivai Gorge, where we've got huge pile of sediments going from a couple of 100,000 years ago at the top down to nearly 2 million at the bottom. The way that's been dated is by using a combination of these methods. It is possible to get samples out of a long stratified sequence like that, and to measure the polarity of the magnetic polarity, and to identify switches where the north-south poles switch. But it's not going to help you because what we know when these are dated by potassium argon dated or whatever is that they're not regular. These switches, you know, from normal I don't know which way around it is here, but anyway, from normal to reverse polarity and back to normal and so on, are very irregular, and some of those are very excursions. Some of those excursions are very brief, and some of them are much longer. So you have to combine some knowledge of paleomagnetism with some potassium argon dating and various other, as many methods as you can. Yeah.
Are they at all predictable? Because I heard I've read something about how it could happen any day.
They can. They're not predictable, but apparently there are maybe some signs that it's about to happen. I mean, no living person has any experience of what it feels like to be reversed, and whether it feels like anything. It sounds incredibly dramatic, and it may be related to extraterrestrial events that are connected to the cause of the reversal. But no, I mean, you can see from that. So if you measure a sediment that you're interested in because it's got some artifacts in, and it comes reversed or it comes normal, it's not going to help. Is it this normal, that normal, that normal? You know. So what you will try and do in a sequence like Olduvai Gorge, where you've got a very long period of time, is you'll try and get a sequence, and then you'll look at the sequence, and you'll try and fit it into this, but you won't be able to do it without the help of absolute dating, because depth of sediment is no easy measure of amount of time. Sediments can build up rapidly and then more slowly, and so on. So it doesn't matter if you get a nice kind of normal, reversed, long. It's not actually going to place your sediments within the global, by now known pattern. So you'll have to get potassium argon dates or some other absolute method. The key thing is you've got to be going for physics. You can't be going for chemistry. Chemistry is are processes that can be speeded up or slowed down. You have to. That's why radiocarbon dating and all the isotopic decay methods are so important, because it's a process that cannot be speeded up or slowed down. So it gives you global applicability and comparability. That's really very, very important. The geomagnetic reversals are not local either, of course, but they need to be calibrated by something like potassium argon. Tephrochronology is something that also came out of those East African sites, because the East African sites like Olduvai Gorge and Orgus Island, very, very important sites with human fossils that are, along with the Southern African, the South African Australopithecine caves in what was the Transvaal, are the most important repositories of fossil human ancestors. And all the way from Ethiopia right down to Tanzania, the Rift Valley is full of hominid fossils which are interstratified with volcanic horizons of ash, where the ash comes out and it blankets whole landscapes. Right? Now, the important thing about those, it turns out, is that every volcanic explosion, I don't know if I can say every, but let me slightly soften that. Volcanic eruptions and depositions of volcanic ash on the landscape are chemically distinguishable from one another. So it's not that every volcanic horizon that people were digging there are the same, no. And of course, potassium argon dating allows you to date those volcanic horizons. What potassium argon dates is not the fossils themselves, but the volcanic ash as it cools. The isotopes of potassium allow you to date those horizons. So from 200,000 down to 2 million, you get a whole sequence of differentiable volcanic horizons which can be dated. That's why we know it goes from 200,000 near the top and 2 million at the Very, very valuable. Of course, in areas where there's not a lot of volcanic material, you can't do that. You have to look for another method. But then another phenomenon that's recently come out of this, and that is that we now know that about 74,000 years ago, there was a massive volcanic eruption in island Southeast Asia. And it spewed out stuff that made a kind of a global winter. It blanketed the sun for a very long period of time. And you can find that ash that's come out all over the eastern Indian Ocean. And so the idea grew that maybe we could find some of those ash deposits and the little bits of glass which are contained within the ash, volcanic glass, not architectural glass. And that therefore we might be able to do something like sort of put a global datum horizon into a whole series of sites, including sites in southern Africa. You find those same eruptions in the ice cores and in the deep sea cores. So these are massive. This was a volcanic eruption like nothing we've ever witnessed historically. So, and it turns out that when that Mount Toba was dated, it's about 74,000. Now that's a really interesting moment in human history, 74,000, because it's around about the time when modern people were first emerging. Beyond the range of radiocarbon dating, which we were banking up against for a long time, and it would be a datum point if we could find it in all of our sites. Then the localized stratigraphy of one site could be matched up with the localized stratigraphy in another site, and that would turn local stratigraphic things into a more global absolute thing. It would give us a datum horizon that we could well use. So people have started to look for that Toba. And Toba is chemically identifiable, right? In other words, we can distinguish Toba from other eruptions. And of course, we've got the date. So, and I think, as I've said once or twice, the origins of modern people, we have many reasons for believing that the origins of modern people, origins of people with our morphology and behaviorally innovative, right, like modern people. So both from the biological point of view and the cultural point of view, people who we would regard as modern, like us, skeletally indistinguishable from us, in fact, not behaviorally and culturally not distinguishable from us, because obviously they weren't using cell phones and whatever, but they were, but by behaviorally modern, we mean that they were behaviorally indistinguishable from modern hunter-gatherers who've been observed quite carefully in the last couple of hundred years. In that sense, they're modern. If they'd been sent to a good school, they would be using computers and cell phones. They were us, you know. Artifactually, they had a long way to go in terms of cultural and artifactual developments, but they could have managed it as far as we can tell. So there's Toba, and these are oceanic places where the Toba eruption has been found. So the question, and it's been found in the sediments of Lake Malawi. So that gave local archaeologists the thought that maybe we could start looking at these crucial sites down in the Southern Cape, where we have the first signs of behavioral and anatomical modernity, that we should look for it there, because even though the sites are close together, one's near Mossel Bay, and another one is out just beyond Plettenberg Bay, and another one is up in Natal. That's not far away, but it's too far to share a common stratigraphy, right? So we're looking for any way we possibly can of fitting the Natal sites together with the Southern Cape sites and the other ones in the Western Cape. We're looking for any datum point that would allow us to shuffle these stratigraphies so that they'll fit together. And we're getting it out of luminescence dating, but sometimes, and the reason why this was so interesting was because the people doing the luminescence dating couldn't agree on how old some of these sediments were. It's all very well as talking that these are science and they're based on physical processes of isotope decay. But when you start probing these techniques and you start looking at what the people in the laboratories are having to do, you find that you know, that there's a bit of fuzz that the scientists have to sort out. You know, it's not as absolute as, you know, the scientist when he or she is writing for their fund proposal. You know, it's not quite. Anyway, and so we've now got the first evidence in some of our sites down there that we do have toba. We do have toba. We do have material that's been moved in the upper atmosphere for I don't know, 1,000 kilometers and settled. And talk about finding a needle in a haystack. What you're looking for there is microscopic bits of volcanic shards that you can then do the chemistry on. So that's looking very. It's not complete yet, but it's been done in the southern coast. We were excavating a site on the west coast near Elands Bay. Those of you know the west coast, and we've looked for it there. And I'm told that they found it there. We had to go back and open up the excavation and do a special search to see if we could find it. Apparently it's there, and that would be very helpful. Okay. Then what Vincent goes on to, and this would be very variable depending on the archaeologist giving the course. A short history of archaeological thought. What are the significant events in the practice of archaeology, in the way people have done things and what they thought they were doing? Vincent and I, as I've said, come from different ends of archaeology, and so we might have quite different notions on this. But I think his overall sequence is correct. There was a long period when people were speculating about the past and didn't really have strong techniques and methods to actually do that. And then things started to speed up. We got developments in excavation. People learned to excavate more carefully and more, and so they got more out of the excavations. And we went into what you might call a kind of culture history approach. No absolute dating methods yet, but obviously people were noticing things. I mean, the one he talks about here, the so-called 3A system in Scandinavia. People were digging holes, and they could see that only at the bottom of their holes, in what they could see from stratigraphy, were the most ancient levels, but they didn't know how actually absolutely old they were. Did you get stone artifacts only? And then as you came up through the sequence, you got bronze artifacts, and then higher up the sequence, you got iron artifacts. So they developed this stone, bronze, and iron 3A system. It was useful. It told them something about the development of technology, that people learned to smelt and make artifacts out of bronze before they did the iron. And locally people were doing that all over the world, and they were learning basically from the stratigraphy something of the culture sequence that was helpful. And then later came methods of absolute dating. Initially radiocarbon dating, and then other kinds of isotope decay methods, and then this whole host of things that Vincent has just been illustrated. What I think is important about this is something about how what he's talking about in terms of the development of archaeological thinking intersects with the enormous variety of things that archaeologists do, and places that they're digging, and interests that they have, and related disciplines that they are linked to. And so what happens is, as archaeology develops, it becomes extremely broad. And the role of science and the extent to which archaeology, and we're in the science faculty, which may seem a bit strange, and I think I can speak about that. But some archaeologists are basically art historians. Some archaeologists are basically historians. Some archaeologists are basically anthropologists. They're humanities type people. But some archaeologists, for instance, a good example, are physicists or chemists. You go up to the laboratories in the archaeology department up there, they are chemistry labs. And the people they talk to and whose language they can understand are chemists. Right? And through what I think Vincent's illustrating this part of the first week's lectures is the way science has been not there in the speculative phase, then has been there in the form of processual archaeology, which is a term that was invented in North America. But what that was an attempt by archaeologists to show that they were also scientists, that they were also doing things systematically, and that they needed to be taken seriously, right? And then so-called post-processual archaeology is a later post-1980s kind of thing, where postmodernism started to impact archaeologists, and archaeologists, some archaeologists, but obviously not all of them, decided no, they weren't scientists, they were historians, and you might never be able to develop a truly scientific approach to understanding the past. But what was happening was, of course, that it was a kind of a split, if you like, between those humanities archaeologists and the people they like to talk to, and the methodologies and theories that they like to borrow from anthropology or wherever. And on the other hand, the science archaeologists who wanted to be considered scientists. And this, well, it's still there. And where Vincent ends up is by talking about the present day as being very interdisciplinary. But the disciplines that, when I first came to South Africa, the only people I talked to really were marine biologists and botanists, because I was very ecologically interested. I wanted to do good ecology of hunter-gatherers here. And I found it really valuable to talk to those people over there. But I didn't really talk to the chemists and the physicists. That was still to come, if you like. But if I'd been in another department or another context, or if I'd been studying the rock paintings at that stage, which I wasn't quite doing yet, I would have been talking to the people down at Michaelis, and I would have been, and I wouldn't have been talking kind of science language. So that's what it's doing. The speculative phase then, rather poor excavation, rather crude understanding of stratigraphy and association and context and so on. Big excavations. If you're doing it, if you've got a kind of crude framework, you can dig big holes. You can dig a lot, and you want to dig a lot, and so you have these excavation drawings or diagrams where people are shoveling using crude methods, and so their understanding of association and context and stratigraphy rather crude. Darwin, very significant impact on archaeology in the middle of the 19th century, leading to much more careful excavations and a much better, but still pre-absolute dating understanding of the sequences of events, whether it's the way stone artifacts change or later on metal artifacts. I mentioned very briefly that hoax in England. This is the so-called Piltdown fossil, which turns out to be a hoax, and where the person not only put different parts of different species together in the hope that it would improve the claims of British fossil studies to be included in the origins of modern people, but also went to the trouble of putting other kinds of fossils which he gathered. It's never been, I think we know who it was, but there's a certain amount of careful talking about that. But putting some animal bones from North Africa and some other animal, because he wanted it to look persuasive. Hoaxes are very interesting because usually, and in fact, amongst those people there, not usually, but often, what's happening is amateurs, so-called, are trying, who may feel underappreciated, are trying to show that those professionals, those academics, don't really know what they're talking about. That they can be fooled, and that's what was going on. And it's a lovely story if you want to read it. You'll find it quite easily. You've got several books. The Piltdown Fortune, the Piltdown. You should read it. It's really. At one point, there was an artifact found that looked like a cricket bat. And so people started to think, was this guy joking here? Was this a joke that went wrong? And was the hoaxer trying to kind of give himself away, if you like, by putting a cricket bat there? Of course, nobody thought it was a cricket bat because it would have been a silly thing to find there. There were a lot of very famous people. Sherlock.
Conan Doyle.
So Arthur Conan Doyle lived nearby, and he got dragged in, whether he was part of it. Various clerics. Anyway, very interesting. That's not Arthur Conan Doyle. Anyway. From those early days, excavation techniques improved, and various, mostly European archaeologists were involved. Gordon Child was an Australian actually, but he was working in England. Dorothy Garrett, Kathleen Kenyon, who was digging at Jericho in the Near East, and Gertrude Caton Thompson, who was digging at Zimbabwe, Great Zimbabwe, and in the Fayum Desert in Egypt. So these were figures that Vincent has identified as people, amongst many, who were realizing that unless you dug pretty carefully, you were not going to get detailed or resolved historical narratives out of excavation. The Leakeys were digging, that's Lewis and Mary Leakey there. They were excavating at Olduvai Gorge, which I've just been talking about. That is Olduvai, and you can see the stratigraphy there. And it's vast. The gorge itself is about 30 kilometers long. It's got a side gorge, and there are hundreds of sites there. And it's about 2 million years at the bottom. Preservation is very good. And so these were the first East African excavations that made it into Nature, the journal Nature. These were, top top quality, the highest quality of excavation of significance. It was just when potassium argon dating was being developed, and so to find, in fact, this is what they found here, to find hominid fossils at 2 million years was dramatic. And what Mary Leakey also was developing was the idea of living floors. So what she realized that if you dug very carefully and you dug spatially, you might find a so-called living floor, which was the same kind of thing as a campsite that you would find in the Kalahari. If you went to the Kalahari and saw some hunter-gatherers and mapped the site that they were living on. So she pioneered this notion of living floor. And they found fossils on these living floors, and the problem they had, in a very famous phrase of Louis Leakey, was distinguishing the dinner from the diner. They found two hominids on one floor, clearly different from one another. And when the first one they found was a kind of very robust individual. And so they assumed that this must be, and there were lots of stone tools associated, so this is stone tool making. Then they found a more gracile individual on the same floor, and they thought, wait, no, this was the dinner. You know, so their eventual conclusion, the gracile individual was making the artifacts, and the robust individual was there as the consumed partner in this relationship. So this is enchantment. It's a cast, not a real thing, obviously. And I'll talk about it just now when we get to a later illustration. So I think that processual and post-processual are not chronological stages in how you do archaeology. They're ways of doing archaeology which depend on whether your connections and your links are with humanities subjects and your interests and what you're trying to reconstruct are humanities related or whether they're science related. You can ask Vincent, but the phrase that was very common in the post-processual era of the 1980s was, let's celebrate ambiguity. I always hated that. The woman who said that to me was a good friend of mine, but I thought, why do we want to celebrate ambiguity? Ambiguity is mess. We want to eliminate ambiguity. Science wants to eliminate ambiguity, but the humanities archaeologists didn't want it. They love talking about, well, maybe, but possibly, you know, whatever. And you all know the post-processual. How many people in here are people that basically would describe themselves as humanities people? Not many. And science people? Yeah. So you're not going to get anybody over there in chemistry saying, right chaps, let's celebrate a bit of ambiguity here. No. Let's do an experiment that distinguishes A from B. Let's not glorify the idea. Yeah. But I can assure you, if you look at ethnography and anthropology, it's full of a tolerance of ambiguity. He talks about Ian Hodder in the post-processual objectivity is not possible. Now, if you go, I am pointing the right way, aren't I? Yes, down the science it wouldn't be a very popular idea. But if you think about it, there is a point to it. You know, and I have a personal problem with the word data. Right? Data means things given. They're not given, they're taken. A biologist, a botanist looking down a microscope is looking down the microscope. You know. And over that side, you know, they'll tell you to write your thesis in the passive. You know, something or other was set up and was examined. No, it wasn't examined. You examined it. I'm getting on one of my hobby horses here, so I should stop. But you can see that this is all possible in such a broad swathe of investigation as archaeology. And then here are some of Vincent's thoughts about contemporary archaeology. Diversity of voices, well thought of, certainly a greater diversity of voices than previously, but as he says, still lots to do there. post-processualism mostly dead. Vincent, I think, would like to think that that's the case, but it's just because it's here. Our department is dominated by scientists. Yeah, our department is dominated by people who are whose closest allies and comrades are biologists and chemists and physicists and so on. There are very few departments that have a laboratory section, and if you haven't seen it, you should go and have a look. I mean, maybe Zav can show you around. However, I think Vincent is right that it's marked by great interdisciplinary or cross-disciplinary or transdisciplinary work. Now, we finally reached the second week. So this week, moving on. This is a nice illustration, but it's way beyond the origins of people. This is the asteroid that struck the Earth in the Gulf of Mexico and extinguished most of the dinosaurs. So until the dinosaur reptilian range of animals were eliminated, there was no room for mammals. So then mammals grew. There were some mammal-like reptiles at the time, but then it became an Earth populated by various kinds of mammals who diversified, eventually developed into primates and humans. So I won't dwell at all on these early phases. Vincent's understandably pointing out that, in fact, the geography of the continents and so on still had to develop because the plates were still moving around. And so global climates were very different at those times. This is important because as we get into the hominids, there are various okay. So the people who look at the archaeological record can be divided, if you like, into those biologically orientated people who are looking at the people, at our ancestors themselves, the fossilized remains of humans, hominids, and hominins, right? Because obviously when we're excavating, we find human remains. And those, on the other hand, who are looking at the artifacts, because the characteristic, probably prime characteristic, of the lineage that leads to us, as compared to the other primate lineages from which we have evolved and separated, is artifact making. That artifact making, brain size, and bipedalism, and various adaptations to the hand that allow us to not to be tree orientated, but to be bipedal on the ground, hands-free, artifact making, and so on. Right. So, and that's one of the features. Obviously, if you've got a foramen magnum that through which the vertebral column enters vertically, then you've got a bipedal. But that's, you wouldn't stop at that. Obviously, you'd look at the heel. We would look at the heel to see the way the morphology of that was organized, and you'd look at other parts of the body to confirm that you're talking about a bipedal. And increasingly bipedal, because obviously when we started out differentiating from our common ancestor with the chimps, we weren't very much different. We went from being the same population as we're going to become chimps and us to marginally different to increasingly different. Okay. So that's And we teach that in our department. Becky Beckham teaches that aspect of shocking manipulation. Eventually, the continents took their present location. The formation of this circum-Antarctic current is very important because it determines a lot of the climate zones of the Earth. But the fundamental thing that goes through the last 2 million years and even beyond, probably one of the main driving forces of human evolution is the gradual lowering of global temperatures, and in particular the cyclicity of it. It's not a smooth lowering, it's very cyclic, and it's marked in the early days by a relatively rapid cyclicity, and then a somewhat longer cyclicity, and then finally over the last 2 million years or so, a cyclicity on about 100,000 year cycle. And these are glacial, interglacial cycles, and they're very patterned. And they do some very important things. They, when the glaciers build up in that part of the cycle, sea level goes down because a lot of water is taken up in the glaciers. And so sea level goes down and land bridges develop and large areas, Southern Cape for instance, huge area of the Southern Cape becomes available, becomes land. And then in the interglacial, when sea levels rise again, those land bridges close, islands become islands, and a lot of coastal territory that people have been living on disappeared. Basically, the boundaries here are about when sea level goes down to about 120 meters. When it goes up, it doesn't go up 120 meters, it only goes up a few meters. So the sea level has been bouncing around on a regular cyclicity between about 5 or 6 meters above present sea level and down to minus 120. And these are significant influences on human behavior and significant influences on the climatic coaxing, if you like, of biological and cultural change. And there it is. And that's that's a fundamental driving force, if you like. And all of that is visible in the deep ocean, of course, and in the ice cores. On land, as I said, it's much more fragmented. You can't build a whole sequence like that on land, but you can in the ocean. And the ocean sediments and the ice cores. And then it's got this nice cartoon. I think we should write some music to this, actually. These kind of notions of how the isotope ratios, oxygen 16 and oxygen 18, are a reflection of water temperature. So when you and that is captured in the ocean cores by these tiny little shells from marine organisms that, when they die, sink to the bottom, and so you get these beautiful, long, continuous, uninterrupted sequences from which you can take out these little shells, measure the oxygen isotope ratio between 16 and 18, and that gives you a temperature. We've got oceanographers here, guys, we can go on that. Okay, so what's different about one of these? Maybe I should start with some sensor. Typically, nearly 10 past 7. Okay, I'll show you these bottles.